Hello, everyone. How's it going? I'm Elliot Mitchell. I have a company called Vermont Digital Arts. I also co-founded the Boston Unity Group. I recognize a bunch of you from Boston. We're so psyched to have Unite here. And without further ado, I'm probably going to give the strangest talk of the conference. So who is this talk for? Riddle me this. This talk is for artists, primarily. It's also for producers to make sure the artists are doing what they're supposed to be doing. And it's for the engineers who can know why their artists are so insane, but also to be able to talk to the artist. So I'm primarily going to talk about art optimizations. I'm going to focus a lot on 3D, a little bit on 2D, some material shaders and image effects. I have a lot of content for a half hour. A lot of this is very beginner stuff. There's maybe something advanced in here, but it's more a beginner level talk. So as game developers, we wish that all of the game players had these awesome battle stations here to play your games and have them work. But the reality is most people have shitty hardware. And you're up against limitations of CPU, GPU, hard drives, operating systems, Windows, Mac. Right now, how many of you do any kind of VR development? Or how many of you are not doing VR but are interested in it? All right, if you have a Mac, good luck. So I'm going to talk about the more demanding platforms, optimizing for them, which really means you're going to make art like it's 1999, right? So that would be mobile. The mobile market's so fragmented and demanding, and these mobile devices pretty much are about as powerful as about a 10-year-old PC. And also VR. So some of the bottlenecks that happen on the art side is vertice counts. Like, you have to keep the vertice count down. We have overdrawing, like when you have a transparent image over a transparent image over a transparent image or over 3D modeling, the sorting issues will go wrong. Color compression, like what compressions do you use? Like a lot of people want to put in their 16-bit per channel with alpha textures in there, but it's going to kill your game. So you're going to need to learn how to put in the top quality art and then tone it down. So like when you're putting image maps in, texture maps, like maybe you want to put them in at 4K or 8K if you want, but you're going to need to compress them down for each platform. Yeah, the sorting issues and culling. That's the old Unity GUI, right? Sprites. A lot of images use sprites. Sprite sheets are pretty cool. I'm not going to really talk about the sprite system whatsoever. I make 3D games primarily, and I would be lying to you if I said I use the sprite system, except for I do use sprites in the new Unity GUI system, and they're pretty cool. I guess this slide also applies to just animation in general. And then another bottleneck is just complexity. Say you just have a whole bunch of animated skin meshes, and those are sort of like mesh geometry is bound to a skeleton moving around. The more of that, the more it's going to tax the CPU. Just the more calculations that go on, and on VR, you're gonna run into problems, and on mobile, you're gonna run out of your batteries. Speaking of VR, you really need to maintain presence. You really need to be in. The player has to be immersed, or they're gonna lose all sense of the world that you're trying to put them in. And to do that, you have to maintain 90 hertz. And VR is twice the work. You render twice the vertices, twice the textures, twice everything. So take mobile and double it. So there's not going to be a lot of text in this talk, but this is some. These are some of the refresh rates and stats for what needs to happen rendering on the top 3 most popular head-mounted displays at this moment. It's pretty crazy. It's about 3 times what a 1080p needs to be rendered at. And I think the stat that Oculus quoted was about 200 million 33 pixels per second or something like that. Here's the kind of graphics cards you need. So Somehow VR will run on that, but it won't run on a Mac, but it runs on a mobile phone. I don't get it. But the PlayStation seems pretty cool. You just need a PS4 or a Vita. The Gear VR, actually, Land's End, just demoed, I think that's the name of the game. I just demoed it the other day on the Gear. It was pretty smooth, pretty nice. Google Cardboard, I was surprised that it runs on iOS, I just learned. And you need an iPhone 5 or later, or iOS 8. Google Cardboard for Android, I have no idea. I think that is like, you don't know what people are sticking in that thing. So I don't know if I would target that. All right, so some things you need to know to just know what kind of things to look for, what kind of bottlenecks are happening in your games. On the art side is there's this stats menu in the game view. And you can see up there it's showing you, I have a laser. No. Uh-oh. I don't know about my laser. But anyway, it's telling you the frames per second. By the way, this is the blacksmith thing, and I'm using it because you do not want this in mobile. But you can see that it's batching about 605 game objects or model, and you have to check static on your models to get them to batch. If you don't do that, they will not batch, and you will not get that savings. This has a lot of triangles and verts. Verts or vertices, 2 million. 303 pascals, set pascals. When on mobile and VR, you kind of want to stay about under 100. On a PC, I think you can get up into the 100,000, maybe. I don't know. But on a mobile, it's like 100. You want to check out the profiler. And this is up in the window profiler. And this you can, before you try to optimize your art and you put it in, you really want to know what's slowing your game down, you go to the profiler, and it will tell you what's rendering, how much memory is being allocated, what time is being used to do what, and you can drill down a little deeper into the deep profiler. It's in the same window. And you can really go down to, you can drill down and figure out like what is taking the most GPU and CPU, but except for on the Mac, again, it won't show you really what your GPU is doing. That works a little bit better on a PC. Then there's this other tool that's really cool called Resource Checker, and it's on GitHub. And this is really cool because it's open source. I think you can get it on the Asset Store, and someone just updated it for Uni 5. But this will tell you every texture that's in your scene. It'll tell you how many materials are using it, how many materials are in your scene, how many game objects, and you can click on it, and it'll highlight them all in the hierarchy or the editor. And that's really, really cool. So it goes for textures, materials, and meshes. And you can see here that those are a hell of a lot of verts for that. 63,000 verts. This is, again, the blacksmith demo, which you can download for free from Unity. But I highly recommend getting this. So now I'm going to talk about optimizing geometry a little bit, starting with 3D. As you know, 3Ds are made of vertices, and they exist in a 3D Cartesian space. And so you always want to have Y up. Whenever you're exporting out of a 3D application, whether it's Maya, Blender, whatever, you want to export with Y up and Z forward. So a vertex has 4 sort of, I don't know if the word's component, there's 4 elements to a vertex. There's position and world space. There's the UV coordinates, and we'll talk about UVs more, but they're sort of how the model's unfolded into 2D space. There's a vertex normal, which is the way that it calculates the way it's facing, so when a camera hits it or light hits it. And then the tangent, which has to do, it's a bunch of math, and it has to do with getting light mapping and normal mapping and bump mapping working. So it calculates how light's hitting that. And there can only be one, right? Of any of those elements. If any of those elements have more than one, then the vertex will split. And I'll get more into that too. So GPUs like 3. They like triangles. If you do not put something in to the GPU that is a triangle, it will split it and make it a triangle. Artists like 4. You model in quads. If you do not model in quads, like you're crazy, right? And I'll get into why, but you model in quads, GPU likes 3, what are you going to do? All right, so triangle, quad, and then the top shape over there is n-gon. Oh, God. Hold on a second. So the n-gon is 5 or more sides. And you can see when the triangle, when you split a triangle one more level and subdivide it, it's still a triangle. The quad turns into two triangles. So when you model in quads and you bring it into Unity, Unity is going to turn every quad into a triangle automatically. So you don't do that ahead of time if you plan on ever editing that art again. And then if you put in an n-gon, you see it creates 3 triangles. And down below, if you subdivide that again, then you start getting all quads, but they're really weird. And just to show you why, another reason why you don't want to use n-gons is that you'll get all these random subdivisions if something happens. And how are you ever going to fix that or work on that again? N-gons are the devil. All right, so let's talk about, I talked a little bit before about GPUs splitting vertices. So there's 3 primary ways in my mind of how to prevent that from happening. First is good topology. I don't think anyone at Unite has talked about good topology. Like, if I'm wrong, like, call me out on it. But I don't think I've ever heard that at Unite. And that's good modeling practices, being a good 3D artist, or if you're not, like, being able to recognize what good topology is, like if you're a producer or engineer and you're wondering why you're having these bottlenecks. The other are hard edges. And I'll go into this. When you have a hard edge, it will split the vertices. The GPU will, because it will, we'll get into that in a minute. And then UV seams, and that's sort of how you unwrap a character, where you put seams, so where the textures go, how you unfold a 3D object. And you can't put lipstick on a pig. If you don't do these things, it's still going to look like shit with the texture. OK, so here's some stuff about good topology. And the head on the right, that's actually slightly misrepresentative because those quads are smooth in some 3D program. It's just showing you a preview what it would look like if it was smooth normals. But you can see there's loops that sort of go around the eyes. Those are called edge loops, around the mouth. So when you're animating it or texturing it, it will have good deformations. If you don't have that, it will crumple. If you had an n-gon on it, it would pinch or collapse. Around the hands, like on the knuckles, the hands will bend properly. The knuckles will bend. There's a space between the fingers where, like, a lot of people model this little V. So just good topology. Here's another PG-rated photo of a guy. And you can see how the geometry, the lines, those are the polygons over the texture. They make sense where they go. They go with the flow of his anatomical structure. So when that model is going to move arms, you can see, or do anything, you can tell that the geometry is going to deform right, and also it's symmetrical up the center. You always want to mirror up the center of something symmetrical, and you want to make sure that there's not double vertices, because sometimes people model half the model, mirror it, and put them together. They need to weld those vertices. You'll get double geometry there. Also, for UV unwrapping, which we'll talk about in a minute, this sort of geometry is really good because you can intuit where you would, like, if you're going to cut that person up and unfold him, like, how would you do that where you wouldn't notice? This is an example of good topology on the head. Here's a very high resolution sculpt in ZBrush. I didn't make any of this. I'll say that. I'd brag if I did. So this is a very high resolution model in ZBrush, and on the side is a retopologized model. That's where the artist will take a high resolution mesh and create a low resolution mesh over it so that it'll actually run in a game. And you can bake a map, a normal map, which we'll go into, that's the difference between those two. But you know what? Keith Richards doesn't like me to say he's normal. All right, so let's just move on. So we'll use chickens. So here you can see that there's sort of a low-res chicken, and then a medium one, and an even lesser one. So these can be also called LODs. And so the distance that your model is from the camera, you set up for the model to swap out to a lower one. So say, like, the chicken's right here, it's the full res one. If it's over where Trevor is, it's the middle one. I see you. And then if it's way in the back of the room, it'll be the little one, or it'll just, like, sort of go away. And the same thing happens with textures. They're called mip maps. And we'll get into that in a minute. But there's these LODs and mip maps. And they swap out, and they save you rendering. About the normals again that we started talking about. So here's 2 cubes. They're identical in every way, except for that one looks weird on the far side. And that's because the one closer has hard edges, and the one further away has soft edges. And soft edges are more for smoothing. And if something is like a rigid shape, you want to have hard edges. On on this, but there's a surprise with this. You ever put a model in Unity and realize that like in Maya it has one vert count and in Unity it has another? That's caused by these hard edges and UVs. And so if you can see over here, this is in Maya. And for those of you who use Maya, there's display menu, and you can go to heads-up display, poly count. And when you select an object, it'll give you these stats. So those little lines coming up diagonally are the vertex normals. It's the way that the normal is pointing. The normal calculates light, and it's an average. Each of those normals, I should go back, sort of the big empty space between the vertices are faces. The lines are edges. The faces have normals that come out, and the lines on the vertices are the average of those faces around it. So a soft normal, it's showing on the bottom number that it has 14 vertices, even though you only see 8, because it's unfolded in some way in UVs. You could put all those UVs together and still have 8, but it'd look really weird. This one over here, we made hard normals, and what it does is, because it makes a hard edge, the GPU can't average it and keep it sharp, so it splits it. So each vertex has 3 normals. So this one's 24 vertices for the same model, but it's just how the edges are hardened or softened. That used to drive me crazy. So on a sphere, it's smooth. Smooth normals, and you think that's cool. On this low poly, so the one that looks smoother and high poly actually has less vertices than the one that looks lower poly with hard edges. So it's funny, a lot of games are like, oh, we're all low poly, whatever, and they're actually more vertices. And you can see here how they're split, like the difference. So you have 4 vertices, 4 vertices, normal vertices for each vertex on the smooth one. So this one has 4 times more vertices because it's harder. This I actually did make this. So robot roller disco derby dodgeball. This is a concept piece for Eric's game, and the model on the far side is kind of hard to see, but this has no normal map. You can actually bake the normals into your mesh without even using a map. And so what I did is I creased edges in Maya, I brought it into ZBrush, and then just exported it right back out. That's all I did. And so this one on the side, it kept data of sharp, crisp edges, and then anything that wasn't, like on the arms, it smoothed. So, and then in Maya, I exported those out, and I didn't have to put a normal map on it, so it saved texture. And so here's the export thing. So, the import setting. So you always want to have your meshes at a scale of 1. And so when you model in, say, like whatever application, you want to model in Maya Unity units and meters. When you bring it in, you have the option here of normals import, tangents import, or not. And that's like one of the most important settings besides generate light map UVs. I always turn mesh compression off. It kind of messes things up. So if you, say, made a model like this, you want to import the normals. If you made a model like that sphere, you don't necessarily want to import normals. If you have a model that uses normal maps, which we'll get into, you usually want to have your normals on the object about set at 180, and you can do that, and then it will average it. And then tangents, you can play around with importing or not. Tangents, again, I can't really explain how they work. It's math magic. But you can, I say open up the stats window and turn tangents on and off and see if you see a difference. Also, if you have an object in a scene and you scale it, you may have to recalculate the tangents or normals if you're calculating them, because they'll have incorrect shadowing on them with global illumination. So here is actually generating, using a normal map to generate a difference between adding more detail from these 2 faces here. So it's a map, and it's unwrapped nicely. So on this one, like the normals are just smooth or just average in the middle, and the map adds the detail. UVs, and I'm going to pick up the speed now. So UVs are unfolding an object into 2D so you can unwrap it. So that first cube I showed that only had like 14 vertices, it was unwrapped like that, like this. And so there's only a couple seams, and it's just unfolded. And it also fits within this quadrant, which is 0 to +1, 0 to +1. There's 4 quadrants. And if you go beyond that, it will start to tile. You always want to keep within there. Oh, sorry, going back 1 second. Enabling generate light map UVs. If you don't make a second UV set and you plan on light map baking, you have to set that, or stuff will look weird. This is the other way to unwrap this. I just auto unwrapped it and like never auto unwrap. And so now you can see this has 24 vertices now because I just unwrapped it like that in UVs. So UVs make a difference. When you look at your artist's work and asset store work, look at the UVs. If it just looks like that, it's weird. Plus those UVs, those shells come right up to each other. Have you ever noticed the model that has like weird dark lines when it goes back? That's because the UVs are either too close or the textures haven't been painted over the UVs enough. So if you did that, you would get the texture from the next section bleeding in. This is a decent unwrapping. This is from the blacksmith again. So the hand part's missing, but they're all in one map, and you can see the edge loops. You can see the good geometry. You could go in there and paint that by hand if you needed to, and it's oriented in a way that you could paint it. That's Maya auto unwrapping. Good luck painting that. Pull it away from the camera, everywhere. This is from the blacksmith scene too, so all that geometry on the top of the Challenger on that one, it's all atlased. It's all put into the same UV map, so you can take all these different models separately and then combine all the UVs. You put them on the scene once, and you can move the UVs to all fit within that coordinate system. They can batch textures and materials that way, so that saves you draw calls, materials, and all that stuff. It's a good practice. Here you can see that the mesh fits over the head really well, and it might be hard to see, but there's overpainting of all those lines. I just projected the lines on there so that there won't be seams. All right, so what source files do you use? I recommend bringing FBXs into Unity. Don't bring anything else in. You can bring in Maya, but anyone using it is going to have Maya on their computer. It will crash. Same with all the proprietary packages like that. I would just use FBX, not triangulated ahead of time. I'm just going to leave it at that. OK, now we're going to get into textures. I usually use the advanced texture type. It gives you more options, and you can drop down. Is it a normal map? Is it a light map? Is it a cookie? A cookie is sort of a texture you put on a light to fake shadows. Generate bitmaps is really good. It does that level of detail. You really never want to have read-write enabled checked ever unless you're checking textures through code, or else it doubles the memory of every texture. And that's not good. Here are some maps that are generated. So we have what they used to call a diffuse map, AO map, and a normal map. And to also save, like on mobile and VR, you want to sort of say you have like highlights and shadows. You can do all this AO stuff. You kind of want to combine those textures together instead of using the separate ones to get more performance, less textures. Every texture in a material is a draw call. This is what ZBrush does when it auto unwraps UVs and makes a texture. That's a face. Substance, algorithmic substance is crack for artists. So the procedural texture generation, and it can either be a very small file and generate in the game, or you can bake it down to a texture, but it'd be really hard to paint that. Another way to also get rid of seams is just to use a 3D paint package like Mudbox, ZBrush, Algorithmic, and paint on the models in 3D so that you're not doing it with Photoshop and you don't get these seams. But that's a nice Atlas 3D thing. And then you can save draw calls also by having multiple objects in your game using the same texture, as many as possible. So this is an atlas from Gamma Sutra, a website I stole, that just has a bunch of art. So there's all those models share that one texture. And you can actually have quite a large texture. It doesn't matter, like whatever the device supports, 2K, 4K, whatever. It's going to save you from having, it's going to save you performance from having multiple other textures and materials. Size matters. You need to model things in scale. Before you export out of whatever your 3D package is, or when you order an artist to do something, it needs to be built to scale. When you start scaling things in Unity, because of the tangents and the normals and how Unity does this magic where it brings it in and it makes like Maya files 0.1 and all this weird shit, you do model in meters in say like Maya, and then you export in centimeters, and then it will come in at a scale of 1. And I just figured this out like 3 days ago.
7 years it took me to figure that out.
Yeah, 7 years. It's black magic. You also want to have your model centered. You want to have on the origin centered. You want to have transformations frozen to 0, 0, 0. So there's no scale. Scale is 1, 1, 1. Transformations are 0, 0, 0. You want to delete all kind of history from your models. You don't want anything in that model except for in its pose, and it should have its UVs and stuff already. You want to bake down animations. You want to have this. You want to have like your in-game animation skeleton. Then you want to have your game skeleton. So your game skeleton is as few bones as possible. You also, there's something called skinned weights. You paint weights vertice to joint. Animators are going to want to do like 4 or 5 of those. You probably want 2 or 3. You can set all that in the quality settings also, what it will accept. And then you bake down your animations onto the skeleton, and you export those in a logically named way. So say you had run.fbx, and you had, or like guy.fbx, and be like guy, run fbx, guy, whatever fbx. Don't put all your animations in one file. It's crazy. And so right here, this is exporting out of Unity. I mean, Maya, what you'd want to do is I actually select a lot of times tangents and binormals, smooth mesh, reference asset content might be, it will bring a texture or material information over. I don't check automatic for scale factor. Even though I modeled it in meters, I put it to centimeters because Unity is going to say that was made in Maya, and I'm going to do something to it. And you always want to have Y up. And for FBX type, you can use 2014, whatever is newest, but generally if things go wrong, you just keep dropping it till it works. I have a few more minutes. Materials, there's all kinds of physically based materials in Unity. They all look great, and they don't work on mobile. So here's a shader. This will never work on mobile, but on VR it could work. And what happens is this is way too, all those little textures and things in there, every one of those is a draw call. And it's cool to have as many models using the shaders as possible, and materials as possible. But try to cut it down. You just want to sort of use the mobile versions, and they're almost as good. Like, just go for the least performance-intensive shader you can use. You can make pretty cool shaders in ShaderForge, and it will compile down the code also, and you can sort of play with that. But don't do any crazy math in it, or it'll also use more CPU. Let's talk about lighting for the last couple of minutes here. Lighting is very important. So Unity has global illumination, real-time lighting. They say don't use that in mobile, but I'm making a game on the iPad right now, 60 frames a second, real-time lighting, global illumination. I'm just building the IL to CPP and using metal. And so on an iPad Air 2, it rocks. Like, it could probably run at 90 frames a second if it wasn't throttled. And see that light coming through? You can use emissive textures with global rendering. You can have the texture emit light. And that's pretty cool. And it comes at 0 cost. It doesn't even cost as much as a light. So I would recommend trying to play with those sort of things instead of using regular lights. Oh, did I pass light mapping? I think I lost a slide. Light mapping is when you take your lights and you make the objects that you want to look like they're lit. You set them as static. You set the lights to the same layer as them or whatever, and you can bake the lights to textures. And there's a real-time one, sort of one, and then there's the baked one. And generally, you want to use the baked one as much as possible, but the real-time one looks really cool, too. And the Atlas is for you. You can make your own second UV sets. It requires those UVs. And I pretty much, back in the day of Beast, you used to have to make your own, or else it would look different on a Mac or PC. The emissive textures again. And then I was just going to talk about image effects. They're really expensive. This one's Chromatica, an example from Chromatica. And Chromatica will take like a whole stack of image effects, and it will bake it down into one lookup texture, and it takes one draw call. So you can put like 15 things together and bake it down into one draw call. It's really cool. It does color grading, and it fixes your textures and stuff like that. I think that's it, and we have like 2 minutes for questions. Yeah.
I'm going to ask 2 questions. You can only answer one of them if there are other people. But I had always used FBXs, but the other day I accidentally just brought an OBJ in. It seemed to work. Is that absolutely horrible?
Oh.
The second one is, what do we think about PBR with Morpheus? Any chance I can get away with that?
For the first one, Unity will convert anything into an FBX, whatever you put into it. So OBJ is OK. And actually, when you export models out of Unity, they're OBJs. It's a weird thing. But OBJs don't carry as much data, but they work. But it will convert it to FBX. And then the second question about Morpheus, I don't really know. I think they announced like more IL to CPP support for Morpheus, so there's probably stuff like that gonna happen. Yeah.
Hi, have you used allegorithmic with, I might be spelling it wrong, but like allegorithmic with mobile devices, and how's the performance?
It's good, as long as you're not animating any textures.
Okay.
Yeah, it's actually pretty good.
What about the terrain engine?
What engine?
The terrain?
Oh, terrain? Terrain's not good with mobile.
Okay.
It's not good with VR. I don't use it. If you look at their blacksmith setting, they don't use it. It's not that optimized. Any other questions? All right, cool. Thank you.